All right. So separating mixtures. So we explained what the mixtures are. Let's talk about separating mixtures. Separating mixtures. All right. So there's two different types of mixtures: homogeneous, heterogeneous. You can separate them different ways. You guys know what this is? Filter. Yeah, it's like a filter for tea. I think it's called a tea ball, actually. Maybe not. Ow! Don't bleed. You son of a... I'm one of those people. Like, get my hand on the hammer and lots of bad things come out of my mouth. Yeah, this thing's opened up. You put tea in there. Actually, I'm having tea now, but it's already in a bag. All right, we're good. You kind of put loose tea in there, and then you put this in the whatever you're drinking tea out of, and then there you go. Why am I showing you this? Yeah, as a filter. Which one could we filter? The salt water, the sand and water, the Italian dressing? Which one could I use this to filter or separate? Sand and water and the Italian dressing. So for heterogeneous, I think I forgot my E there. Heterogeneous, yeah, there's an E there, sorry. Heterogeneous, we can use filtration. Filtration, you saw that in lab. You saw that in lab. So you understand visually what that looks like, right? You had the blue solution, you put the aluminum foil, it reacted, you poured it through the filter paper. What went through the filter? The solution. The solution went through. What stayed on top? The solid. So if we were to pour this salt water, sand water, sounds weird. I mean, I could show you, but I'm trying to save some time. If I poured this through, what would stay in here? Sand. And what would go through? Water. Right. Good. If I poured salt water through this filter or the filter paper in the back, it would actually just go right through. So salt water you cannot separate through filtration, and the reason for that, so maybe leave like 2 spaces here, 2 lines, and then write homogeneous. The reason you can't separate homogeneous mixtures with filters like salt water, because the salt is in the water. It's like in between water particles, so it's small enough it goes right through the pores in the filter. So homogeneous, you can't do that with filtration. What could we do? Evaporation. Yeah, evaporation, right? Evaporation. And we're going to do that right now. So come on back. Courtney, you can't see this, sorry. I think she's going to watch that. Alright, so stay right where you are. Okay, so I don't have goggles on, I'm doing this quick. So this is a setup for evaporating salt water. It's typically not that high, it should be that high, but these burners, if you turn the flame down too low, shoot out the top. So, anyways, this is how we would set it up. There's a watch glass on top of the beaker. We're just heating up water, so that water's boiling, producing steam. The steam is hitting the bottom side of the watch glass. The watch glass is getting hot. So I'm going to pour some of the salt water up here, okay, and then I'll juice this up a little bit. Hopefully by the end of class, we got, almost out of time. All right, so I guess I'll just show you that on Monday, but this is the setup. We'll let that sit, and then Monday we'll come in what should be on top of that watch glass. Just salt, right? So that's how we would prove you can separate this with evaporation. All right, let's go back up front quick. I lost track of time. I thought I had a little bit more time than that. Now, how else can we separate mixture? We can use this method. This is called chromatography. You guys heard of that in biology? Hopefully, living environment. If I take the black or red or blue and I draw a line on this paper, and then I put the paper in the water, what happens is the water is going to climb up the paper, and when it hits the ink is water soluble. So it's going to dissolve in the water. As the water climbs all the way up to the top, if this ink has separate parts to it, okay, well, we'll talk about homogeneous, heterogeneous, but if it has separate parts, you'll see them separate on the paper. That's called chromatography. So I was going to show you that too, but I'm really running short on time. So another way to separate these mixtures would be chromatography. And would ink be homogeneous or heterogeneous? So remember, when you look at it, if it looks like one phase, one thing, that's homogeneous. If it looks like two or more, that's hetero. So what does ink look like? One thing, right? So ink would be homogeneous, so chromatography. And I'm going to explain that more on Monday, okay? We're basically out of time. You do have homework. I know you hate me. That's okay. I can live with that. In your book, nonetheless. Page 83, 15 through 18. Where's the marker? Page 83, 15 through 18. And then just a couple more here. Well, actually a little more than a couple, sorry. Page 95, 57 through 64. Page 99, 13, 15, and 17. And just so happened it's a weekend. Sorry about that. So that's due Monday. If you can get it done before the end of school, then you don't have to bring the book home. And I will text it with the remind business here later today.